Let's see, Sally is excused today, Max here, Elliot here, Jalen here, Nico. Val's here, Andrew here, Tom's here, Olivia here, mobility excused, Rosie. Shango here, and Dallas is excused today. All right, we're gonna spend today using Excel to calculate some values. We're gonna have a we're gonna have a model for exchange rates. So I'm doing this kind of approximately. If this was the derivatives class, we would have used a little bit better math, but change in the stock price, actually percentage change in the stock price or spot exchange rate. Come on. We're gonna have that, let's call this delta times change in time period, or the length of the time period, plus some sigma times a normal distribution with a mean of 0 and a standard deviation of square root of time period, where delta is the difference of interest rates domestic interest rate minus foreign interest rate, and convention we have is value of foreign currency in terms of domestic currency. So what we're pricing is how much the foreign currency is worth. For example, if pricing euro in terms of USD, which is the standard convention in the market anyway. So just use standard rate from the market. If pricing, for example, Swiss franc in USD, we would use CHF USD, which is the reciprocal of USD CHF which is standard in the market. Here, time is measured in years. Delta, which is the interest rate differentials, is an APR term. That's why we multiply it with delta t, to get the period rate. Basically, what we're going to do to generate a path of weekly prices, we will set delta t equal to 1 over 52. Remember, 52 weeks in a year. We will let S0 to be current spot exchange rate. And for each period, we will have a randomly generated number, and let's call that NT, which is going to be a draw from a standard normal distribution. And in Excel, we can do this by using the formula. So NT is going to be norm S inv. It basically means inverse of the standard normal. Rand is a random draw from a uniform distribution between 0 and 1. Hence, ST plus 1 is going to be, or let's do it this way, ST plus 1 minus ST divided by ST, which is the change, percentage change, is going to be delta times change in time plus sigma times square root of change in time times NT. Alternatively, ST plus 1 is going to be ST times 1 plus so this will generate a path, and for each path we're going to calculate some payouts. But let's go ahead and develop our paths first. Notebook. We have some parameters. I'm going to put in delta t first. In this case, it's going to be 1 over 52. Okay. Sigma, which is the volatility. For now, I'm going to put 10%. delta, which is the difference of the interest rates. For now, I'm going to put about 2%. Since these are going to be inputs, we can always change them. And I will also have the current spot. Let's find out our spot. I'm going to do this for euro dollar, 107.07. All right. Where are you? Dark green. Oops. And if you look at the formula, there are some things that's not going to depend upon time. So let me calculate delta times delta t. And sigma root delta t sigma times square root of delta t. These are intermediate inputs. Let me make them black and white. I'm gonna actually, let's leave it as like that.